we're picking up the last section in chapter 8.
Yeah, Adam. Wait, why?
Well, because it just made more sense. I'm recording, and you need to sit down because nobody wants to hear your voice when I sit down. We don't want to hear your voice.
I'm not touching your stuff. Plus, you also kicked my stuff.
Okay, we're going to look at some tables. Again, we've done this separately, but now we have to make a decision about what type of function it's going to be. Yes?
I know this doesn't really have to do with this, the log. I want to know how you...
So, if the y coordinates, if we multiply by the same amount, it's exponential. If we're adding by the same amount, it's linear. And then we're going to look at the quadratic table as well, which we have not touched upon, when the second difference is the same. Okay, so if we were to, let's look at number 7 up here. We need to determine what kind.
I bet it's quadratic.
You think it might be quadratic?
Yeah, because if you were to imagine it's going down and then down and then it gets down slower, but then it starts going back up again.
You're right. Quadratic is going to have some symmetry about it. Very good. So quadratic has some symmetry about it. It starts to repeat itself. So if we were to check it, if we were to do a subtraction problem, how do we go from 0.9 to 0.4? Right? And in this one, we'd subtract 0.3. Ladies and gentlemen, I don't need to have all your chit-chat. And the ones that are talking are the ones who aren't writing anything down. How about that? It's interesting. The ones that are talking are the ones who are not writing what they should be writing down. So the excuse of, oh, I'm going to pay attention, I can't write while I pay attention, you're not. Okay, so if we continue this, we would subtract 0.1. However, if we keep doing this, you will notice they are not the same. So it's definitely not linear. If you look at the second difference,
You subtract negative 0.1.
what is the difference between negative 0.5 and negative 0.3?
Negative
0.2.
0.2, What is the difference between the negative 0.3 and the negative 0.1?
0.2.
So now you see that the second difference is the same.
exponential is bonus.
It's quadratic.
Because if you notice, it starts going back up again, and the only kind of graph that goes back up is the exponential.
So 0.1 has to be vertex as well.
All right, let's look at the next one. So if we were to look at those differences, first of all, let's see, does it have any, excuse you, your voice is being recorded right now. I wish you would turn around, please. Thank you. I'm trying to give notes. All right, on number 8, the y coordinates. Do we have a symmetry? Does it begin to repeat?
I just had a question.
Okay, what's your question?
For number 9, what are those 3 numbers that are coming from?
Oh, I'll erase it in just a second.
Oh, okay.
Yeah.
We're on 8, right?
All right, so if we were to look at from one number to the next, what is it going up or down by? By 2, down by 2. And then this one goes down by 2. The first difference is the same, so that means that we are linear. You can look at the first distance.
Aren't you supposed to have her permission to record us? Isn't it illegal?
All right, if we look at number 9, we want to see what's happening to the y's.
They're going down and then up.
Going down and then up, so it's repeating. See the 4 there? So that's a dead giveaway that it's probably going to be quadratic. See where it's Okay, so it's probably quadratic. We need to check that second difference. So it's going down by 5, and then by 3, and then down by 1. And if we look at that second difference,
And it's just like number 7, except that it's not decimal point.
exactly. Exactly. So now our second difference is the same.
Are you
So it is quadratic.
Ms. Bowden,
Yes.
for the second, for 9, the second difference, you're just doing the absolute value?
Yes. Yes, just like the absolute value. Yes.
What exactly are you doing with the numbers? So you're finding the difference between, 9 and 4 and then 4 and 1, and then finding the difference between the difference?
Yes. So this would be the first difference here, and then if I find the difference between those, that's called the second difference. And they're all the same.
It's just the absolute value.
Well, it's going up by 2 each time.
But you already know it's quadratic from, how it goes.
Well, the other possibility for symmetry is if it's an absolute value function, where it would make a V. So that would be the other option for symmetric. Remember what that one looks like? So like it's not going to be doing this. It's not an absolute value. So that's why we're checking that second difference.
Would you have to do that to make sure you're getting it right, or?
In these graph problems, it will be just quadratic if it shows the symmetry. But if you are taking like a standardized test or something, then yes, you probably need to check that second difference.
What's, Ms. Bowden,
Mhm.
what's the, how do you tell the difference between the V and quadratic?
You would probably just have to graph it out. Yeah.
So if it's absolute value, then it's a B.
And you wouldn't get that second difference. You would see the symmetry, but you wouldn't get the second difference. And then you could say it's absolute. Yeah. Okay, let's take a look at the last one. What's happening to the y coordinate?
This Bowden is decreasing by half every time.
All right, good. So,
It's exponential.
right. So this is being multiplied by 1/2.
Every time.
Yep. Is it growing or decaying?
It's decaying, Miss Bowden.
Right, it is decaying. It's going down. So yes, this is exponential. It has a common ratio. All right. Now we're going to go back and write some equations for some of these.
Y-intercept is 3, Miss Bowden.
Mm-hmm.
Ms. Bowden,
Yes.
so, if you, when you, if you were to have like 2 to the x for your exponential equation, then,
Yeah.
Our y-intercept is 3, so it would be y equals 3, and then our multiplier, 1/2, raised to the x power. So there would be our equation. Okay? So if I had like a +2 or a +3 on the end, it would be a vertical shift. And it would change my y-intercept. Okay?
Ms. Bowden,
Yeah.
for the quadratic, how do you know which one's A, B, and C?
We would probably need to look at factors. Yeah. Okay, let's look at the linear one. Y equals mx plus b, right. All right, do we know the y-intercept on our graph?
No.
No, we don't. But we need to find out when x is 0. So we need to back this up. So what minus 2 gives me 1? 3. So our y-intercept would be 3. Back up the pattern. So this would be y equals, our slope is the common difference, so we'd have negative 2x plus 3. There's our equation.
Are you going to do the quadratic one?
I'm going to do one of them, yeah. Let's look at number 9. So we said this was going up by 5. Down by 5. Down by 3. 1. 1 and 3. All right, do we have any of the x-intercepts? No, but we probably could find some, right? When when y is 0, we need to find our x-coordinate. So when y is 0, so here's an x-coordinate. So there's 1.
How is the x coordinate supposed to help?
Because we could get our factor. So 4, 0 would be where it crosses the x-axis. The intercept, x-intercept. So if x... Mr. Keegan. When x equals 4, the factor would be x minus 4. All right, we need to find another x-intercept. You can use that idea of symmetry that you guys said earlier. You noticed that it was symmetrical. So if we were to repeat and carry out our table.
Is it going to be -7?
So what would be 7?
What? 7 would be 1.
Would be what? Would be
7 would be 9, Miss Bowden.
9. So we need to go the other way, don't we?
Yeah.
So what would happen here at 0?
Be 11.
The second difference needs to be 2.
So 11.
11?
Well, 7. I know.
-7? Okay, let's see. So that would give me 2 here, but that wouldn't be a common difference of 2.
It has to go. So you have to find out.
So we got to figure out what would go here.
Again.
So let's see. So that it would be a common difference of 2. So what plus -5 would give me 2?
Oh, you're doing the diamonds?
No, I'm just trying to follow this pattern. So -7 would have to be here. Is that what you're saying?
Oh, that's what I thought, but...
Okay, so -7 would go here. So what plus -7 gives me 9?
We get it 2.
2 would be a 7 difference. It needs to be bigger though, doesn't it?
Yeah. So you would just do 7 plus 9 then, wouldn't
So it'd be 16?
you? I think so.
Yep. So we would get 16.
So that's not a common difference.
Well, between 7 and 5 it would be.
2 is 7.
So 16. So we have to find when y is 0 again. We're going to have to keep going. Well, now I'm not sure. We have an axis of symmetry. So our vertex. Yeah. Our vertex is going to happen at 4, 6 because that's the point of symmetry.
Oh, it's just go negative?
Yeah, so we would use x minus h squared plus k. So we could use the vertex form. Put in our vertex.
Then you make y be 0.
Yep, so we would like,
A is the axis of symmetry.
so it would look like a x minus 4 because h is a liar.
Is it A the axis of symmetry?
No.
What is it?
It tells you what the shape, vertical stretches or shrinks are going to be. Then we'd have to put a number in and solve for A. So I'm going to have to get another sheet of paper here. Yes, ma'am.
I don't understand what's going on.
Okay. So do you understand why? Okay, so we're going to put in 3, 1 was a point off of the table. Let's put 1 in for the y. And we're going to put 3 in for the x. And then we solve for a using order of operations. So a would be 1. So we come back and write our equation. Y equals 1. X minus 4 plus 0 would be the equation for that particular table.